So explaining the reflection, and you need to understand how, not only know how, and you also need to know why. For example, when x equals fx, transformed into y equals negative fx, which you can just separate the negative one. It's equivalent. The purpose I do this is just make sure you understand. So this is the original fx, and then you should multiply the negative one. That's a relation, right? Before you try to get understanding, uh, we can take a closer look at what a function is. To me, function really like machines. Okay, they are machines. So for example, look at this graph. So this is like the input, like a feeder. Okay, you feed something to this machine, and then this machine just produce something, some product. Okay, so to make it easier, we just say, oh, we put the x is input, then the y is going to be the output. And the f really means how y is going to be related to the x. So mathematically, of course, f is just an expression in terms of x, right? If you put x here, it means f is really just a function which is an expression in terms of x. So if you replace the bracket here, okay, the bracket here is really just like the intake here is just you put something in, right? So for example, if we do put an a into the x, and then after the function, it produces a b. So basically, we're saying if we have a point a and b is a point on y equals fx, right? We're just gonna see what's gonna happen to what kind of point is gonna be equivalent, corresponding to a point on the y equals negative fx. Think about this way. So if we still put the same input for the A, put it into this machine, and you can see because the f you didn't change anything here, so you put as x. So after the machine f, they should produce the exact same thing b as you had here. But this b is not done yet. It has to go through another process, multiply -1. So you should produce a negative b. So what that means is if you put the same a on this transformed function, a new function, it should produce negative b for you. Okay, so this is very clear. If you look at a point, its y-axis change to the opposite number. And basically, it should undergo a vertical reflection, which is reflection about the x-axis. Yeah, so that's the conclusion, right? Since you can see one point, it changed to another point with the same x-axis but opposite on the y-axis. And this is not a actual point, it's just a general point. A can be anything, right? B can be anything. So in general, any point on the original function is going to change to this. So we should have this conclusion, right? And then if you do this a similar analysis, so you should be able to figure out for y equals fx, right? If you change it to y equals f negative x, so see what's gonna happen. It's easy to remember the rule. See, if you put the negative on the x, we should have a reflection on y-axis. all we can see is it's going to undergo a horizontal reflection. So now we can try use the same idea to analyze, to understand that's the way it is. I copy the machine, okay, the function machine here again. So you can see same thing. If we have a point A, B is on the original function on y equals fx, so that means the same thing. If you put an A, you should produce B after the function. And here you go. What if we think about this way? If we want the same B as output. Okay, if we want the new machine, okay, so the new machine is different. So new machine is f negative x, but where do we put the negative x? Hold on, we're still gonna use the same machine, but we try to change the how it is being fed. So if we want the same b as output, you have to put exactly the same a into the machine. But the problem is before it's being fed, it should multiply -1. So basically we have to ask ourselves, so what is the number, okay, what is the number that multiply -1 is going to be a, right? So we're asking for what kind of x multiply -1 to become the a. Okay, obviously you can guess. So the question mark, it should just simply be -a, right? So if you put a -a here, -a multiply -1, it should give you the a. So what does that mean? If we want to produce the same b, we have to feed it the machine with -a. So that means we should have a point -a, b on the new machine. Okay, so on the modified machine, y equals f -x. Okay, so that explained. If you have a point after the transformation, it becomes same y, but opposite in the x-axis. So obviously you know there's a reflection on the y-axis, right? Because only the x value changed. If a is +2, now it becomes a -2. So it's go to the other side of the y-axis. Okay, so the conclusion would be exact same as we put it here. Okay, so by the way, we can look at it, the original one, the previous one, like y equals fx transform into y equals -fx, and this one is really equivalent to, if you multiply 1 on both sides, you should get -y equals fx. Okay, so see, if you put a -1 over here, there's no difference compared to the x, right? So -y compared to -x, you should get, if you have a point on the, as we already explained, a and b on this, so we should have a and -b, right? So that would be the same thing. Okay, now what if we want to do this? Y equals -y f -x. Okay, by the way, this one is equivalent to y equals -f -x, right? So they're equivalent, because if you multiply -1 on both sides, you should get this. Of course, we understand the conclusion is let me just modify this a little bit. I just write here as original one. So if this is original one, and then it transformed to negative f negative x, and then we see this one is equivalent. Change this as well. So if we see the original function y equals fx transformed to negative y equals f negative x, this one can be written as y equals negative x, right? And then it looks like we have two steps. First step, we can do this, y equals f x, sorry, negative x. And then we go one more step to get this. Okay, so we should get this conclusion. If we have a point a, b on the original function, and after we've done this, we already explained that we should have a reflection on the y-axis. So we should have negative a, b. And then the second step, from here to here, there's no change on the x-axis, right? Because negative x, you still have negative, so there's nothing changed on how you input the variable, right? So then we still have the same thing here for the x-axis, still negative a. And then because of this negative sign, as we explained, this one, the b, y-coordinate b should be the opposite, so negative b. Okay, so if you consider the two steps, one first, then the other one follows, we should get this conclusion. Basically, visually, it should be we undergo a vertical reflection and then horizontal reflection. Or you start first with horizontal reflection and then vertical reflection. So there's no difference in terms of the order. Okay, whichever comes first, the other one follows. You should get exactly the same conclusion. Okay.